After the defeat of 1918, Germany undertook a silent reconstruction of its military power. Engineers, technicians and officers worked under civilian projects that concealed the true goal: to recover the lost supremacy. With the rise of the National Socialist regime, the entire industry aligned with the war machinery. What began as technical modernization transformed into a feverish pursuit of absolute superiority, where every innovation had to demonstrate the reach of the new Reich. The Landkreuzer Ratte was conceived as a mobile fortress of 1,000 tons armed with naval cannons, the Focke-Wulf Triebflügel, a wingless fighter that promised vertical takeoff, and the Borgward IV, a remotely controlled tank capable of attacking from a distance. They were projects that combined technological audacity and industrial precision, machines that seemed to anticipate the future. In them converged the vision of the engineers and the obsession of a state determined to turn science into power. This documentary examines 20 abandoned Nazi vehicles, whose discovery has revealed the hidden scope of Third Reich engineering. The Landkreuzer P-1000 Ratte, the project of the world's largest tank. At the beginning of 1942, in full confidence from the initial victories, Hitler approved one of the most excessive projects of his regime, the Landkreuzer P-1000, known as Ratte or Rat. The idea was proposed by Edward Grotte, engineer of the Krupp Consortium, who imagined a vehicle so enormous that it could be compared to a warship on tracks. His proposal was formalized on the 23rd of June of that year and was presented to the Führer himself as a 1,000-ton tank, the heaviest ever conceived. The design sought to combine the armor of a battleship with the mobility of a land vehicle. The Ratte was to measure 35 meters in length, almost 14 in width, and 11 in height, with a calculated weight of 1,000 metric tons, more than 5 times what the Maus weighed, the largest tank that Germany actually managed to build. Its frontal armor would reach up to 36 centimeters thick, made of hardened steel. The planned crew exceeded 20 people and could even have reached 40 in charge of handling the engines, the cannons, the ventilation systems, and internal communications. Its appearance resembled that of a true mobile fortress. To move such a mass, the engineers planned to use marine engines, similar to those employed in ships and torpedo boats. 2 possible configurations were considered: 2 MAN 24-cylinder engines or 8 Daimler-Benz MB 501 20-cylinder engines capable together of generating more than 16,000 horsepower. In theory, the vehicle could reach about 40 kilometers per hour, but in practice no road or bridge would have supported its weight. The system would even include breathing tubes, similar to those of submarines, to keep the engines active when crossing deep areas. Although impressive on paper, the real movement of such a machine would have been practically impossible. Its main armament would be a double turret with 280mm cannons, the same as those carried by the battleships of the Gneisenau class. One of the 3 original cannons from the naval mount would be eliminated to reduce weight and gain storage space. These weapons would fire explosive and piercing projectiles capable of destroying entire fortifications or enemy tanks at great distance. In addition, the Ratte would be equipped with a 128mm anti-tank cannon, several 15mm autocannons, and up to 8 20mm anti-aircraft cannons placed in defensive turrets. It was also planned to include a compartment with 2 BMW R12 motorcycles for reconnaissance tasks, a medical area, and even a small toilet, details that reflect the colossal size of the vehicle. The idea arose in part as a response to reports about the Soviet KV-1 and KV-2 tanks, which had surprised the German forces on the Eastern Front. Hitler, fascinated by the idea of creating an invincible machine that imposed fear and power, gave the green light to preliminary development. However, within his own government, Albert Speer, Minister of Armament, was opposed from the beginning. He argued that no logistics system could manufacture or move such a monster. Despite his objections, in December of 1942 the plans were completed and the name Ratte was officially registered. At the beginning of 1943, Speer finally managed to get the project cancelled. His reasons were evident. The tank could not cross bridges, it would destroy the roads it passed through, and it would get trapped in any terrain. Its size made it a perfect target for Allied aviation, and its theoretical speed did not compensate for its vulnerability. Furthermore, no railway could support its weight, nor were there tunnels wide enough to transport it. In practice, it was impossible to use. After the end of the war, the project documents were found in a bunker near Berlin, along with other equally unfeasible designs. Thus ended the history of the largest tank that Germany dreamed of building, a colossal steel fantasy that never rolled. Focke-Wulf Triebflügel, the vertical aircraft. In 1944, when the war was already clearly tilting against Germany, the engineers of the Focke-Wulf Company received the order to create a new type of aircraft that could defend the airspace without depending on runways. The continuous Allied bombings had destroyed many bases, and the High Command needed an aircraft capable of taking off and landing vertically from any available terrain. This ambitious project was given the name Triebflügel, a German word meaning impeller wing. The design was so unusual that it resembled nothing known. Instead of traditional wings, the Triebflügel had a large central rotor placed in the middle of the fuselage. That rotor had 3 long blades, and at the tip of each one a small jet engine was installed. To start the movement, the apparatus would use auxiliary rockets. Then, when the blades spun at sufficient speed, the air would activate the main engines, called ramjets, which would keep the rotor spinning continuously. It was a mixture between helicopter and jet fighter, a concept ahead of its time. On the ground, the aircraft rested on its tail, and its cylindrical body was reinforced with 4 cross-shaped fins that served to stabilize it and control its orientation. At the base, it had a main cushioned wheel, and at the end of each fin, small swivel wheels that helped maintain the vertical position before takeoff. The entire landing gear folded inward once the apparatus switched to flight mode. The pilot sat in the front part of the fuselage, right below the rotor. From there, he had to control the tilt of the blades, which determined both speed and lift. The fuel was stored in tanks inside the fuselage and distributed through an internal pipe system to the engines at the tips. One of the most innovative points of the design was that it did not generate counter-torque, since the ramjets spun on their own, eliminating the need for a tail rotor, as in conventional helicopters. During takeoff, the blades tilted to generate vertical thrust, lifting the aircraft as if it were a rocket. Once a certain height was reached, the pilot had to gradually tilt the craft until placing it in a horizontal position. At that moment, the blades functioned as giant propellers, propelling the plane forward at high speed. To maintain level flight, the apparatus had to keep a slight upward angle, and that is why the nose cannons were designed with a tilt that compensated for that position. The planned armament was notable for its size: 2 30mm cannons and 2 others of 20, mounted in the front part. If it had been built, the Triebflügel would have been capable of attacking Allied bomber formations from short range, destroying them with a few shots. According to calculations, its maximum speed could approach 1,000 km per hour, an impressive figure for a project of that era. Landing, however, was the most dangerous part. The pilot had to reduce speed, slow the rotation of the blades, and return the craft to a vertical position. At that moment, his view was oriented toward the sky, and the ground was out of his field of vision, making it extremely difficult to calculate the distance when landing. In addition, the spinning blades blocked almost all rear visibility. Even the Focke-Wulf engineers themselves admitted that this maneuver was very risky and would require pilots with exceptional training. Only a wooden model was built, used for wind tunnel tests, where its aerodynamics and stability were studied. Before a functional prototype could be developed, Allied troops occupied the facilities, and the project was cancelled. The plans and documents were confiscated and later analysed by American engineers, who studied the concept for several years, although they never applied it to any subsequent development. Kugelpanzer, the relic that no one can explain. The Kugelpanzer is one of the most enigmatic projects of the Third Reich. Its appearance seemed more like an experiment than a war vehicle, a metal sphere with a small rear hatch and a front slit for observation. Only one known exemplar was built, and its fate ended in Soviet hands at the end of the Second World War. To this day, its exact function remains a subject of debate among historians and military technology experts. It was discovered in Manchuria in 1945, when the Red Army occupied the Japanese facilities in Harbin and Mukden. Among the seized vehicles appeared this round machine, painted grey and with a barely visible serial number. The Soviets transported it to the Kubinka Tank Museum near Moscow, where it is still preserved. Its German origin is confirmed by the internal parts, which bear Reich industrial seals, although there is no official record of its development in the German Army archives. The vehicle had a completely spherical structure, formed by two large metal wheels that served both as hull and rolling system. At the rear, it had a third smaller wheel that acted as a stabilizer. It measured around 1.5 meters wide and 1.8 high, with an approximate weight of 1.8 tons. Its armor, only 5 millimeters thick, only protected against light weapons, suggesting that it was not intended for direct combat, but for observation or support tasks. At the rear was a hinged hatch, large enough for a crew member to enter and sit in the center. In front of him was a narrow peephole and two side slits for observation. Direction and speed control was done with two levers. Similar to those of German light tanks, it carried no installed armament, although some reports mention an internal mount for a radio or optical sight. The engine, located at the rear, was a single-cylinder air-cooled one with about 25 horsepower, probably taken from a motorcycle. Thanks to it, it could reach between 6 and 8 kilometers per hour on flat terrain. Soviet tests showed that the vehicle moved with stability, but was difficult to maneuver on slopes. Its range did not exceed 40 kilometers, and the suspension system was very rudimentary. The wheels were attached directly to the chassis, causing irregular movement on hard surfaces. There are no records of series production or official usage orders. German experimental projects were usually identified with the VK acronym, but the Kugelpanzer never appeared under that classification, reinforcing the idea that it was an isolated prototype. Due to its size and characteristics, experts believe it may have been designed as an observation vehicle, or perhaps for laying communication cables under enemy fire. Another theory links it to artillery reconnaissance tasks, where the operator could advance protected to adjust fire. The fact that it was found in Asia has given rise to theories about its shipment to the Imperial Japanese Army as a technological sample during the war. Germany and Japan exchanged military projects, and some models, such as Type 9 submarines, were sent to the Pacific. It is possible that the Kugelpanzer was part of one of those exchanges, although there is no documentary evidence to confirm it, nor evidence of its use by the Japanese. Today, the Kugelpanzer remains a historical mystery. It is preserved unrestored at the Kubinka Museum, showing its strange metallic silhouette and its empty interior. Its origin, purpose, and true tactical value remain unknown. Dornier Do 335 File, the fighter with two hearts. In the last years of the Second World War, when Germany was desperately seeking a weapon that could change the course of the conflict, a machine emerged that was as strange as it was brilliant. The Dornier Do 335, nicknamed File, the Arrow. Its creator, Claude Dornier, wanted to achieve the impossible, combine the power of a twin-engine aircraft with the speed and elegance of a single-engine one. To do so, he devised a unique design, an engine at the front that pulled the aircraft and another at the rear that pushed it. This system, known as push-pull, reduced air resistance and eliminated the greatest danger of traditional twin-engine aircraft, losing control if one of the engines failed. The result was an aircraft that, at first glance, looked like a conventional fighter, but that hid a double heart under its metallic skin. The first flight, in October of 1943, surprised even the engineers. The File reached more than 760 kilometers per hour, becoming the fastest piston-engine aircraft of the entire war. It climbed with impressive speed and maintained uncommon stability for an apparatus of its size. Compared to the best-known German fighters, the Focke-Wulf 190 or the Messerschmitt 109, the Do 335 was a machine from another dimension. Its design drew attention. A long fuselage, a cross-shaped tail that left space for the rear propeller, and a retractable front-wheel landing gear, something almost unprecedented in the Luftwaffe. The cockpit was pressurized and featured an emergency ejection system that released the rear propeller before expelling the pilot, a futuristic measure for 1944. The main model, the Do 335 A1, carried a 30mm cannon that fired through the center of the front propeller and two additional 20mm cannons on the cowling. It could also carry bombs, making it a heavy fighter capable of striking hard. Reconnaissance and night fighter versions were planned, even with radar and a second crew member, but none were produced on a large scale. In flight, the File was imposing. It could outrun almost any enemy and even surpass in speed some first-generation jet aircraft like the Me 262 when flying at low altitude, but it arrived too late. Germany was collapsing, the factories were being bombed relentlessly, and barely about 35 complete units were built. None saw combat. At the end of the war, the Allies found several examples in different states of assembly. One of them, fully operational, was sent to the United States for study decades later. That same aircraft would be restored and today is exhibited at the Smithsonian National Air and Space Museum, where it continues to amaze those who contemplate it. The Dornier Do 335 was more than an experimental aircraft. It was the last great bet of German engineering with piston engines, a machine that condensed the audacity, ingenuity and desperation of a nation in its final hours. An arrow that, although it never reached battle, pointed straight to the future of aviation. Panzerkampfwagen 8 Maus, the Rolling Fortress. At the beginning of the Second World War, the Luftwaffe faced a monumental logistical challenge, moving tanks, trucks and entire troops through the air. From that need arose one of the most colossal transports ever built, the Messerschmitt Me 323 Gigant. Its origin dates back to the Me 321 glider, conceived in 1940 to support the planned invasion of Great Britain, Operation Sea Lion. The Me 321 was an ingenious device with immense wings, capable of transporting armoured vehicles, but its size made it almost ungovernable. It needed 3 Bf 110 bombers or a special double fuselage apparatus, the Henschel Hs 111Z, to take off. The solution was evident: equip it with engines and turn it into a self-propelled transport. Thus was born the Me 323. It retained the tubular steel structure and canvas covering of the glider, but incorporated 6 French Gnome-Rhone 14N radial engines, 3 on each wing. With them, the Gigant could lift more than 10 tons of cargo, from light Panzer I tanks to several Kübelwagen utility vehicles. Its cockpit, located above the fuselage, housed 2 pilots, a mechanic and a radio operator. Coordinating the thrust of 6 engines required almost surgical precision. Each power change had to be synchronized manually through a complex system of levers. The front fuselage opened like a double hatch, allowing trucks and supplies to enter directly into the hold. The floor, reinforced with steel and wood, included anchors to secure the cargo during flight. Although the maximum speed did not exceed 270 km per hour, the Me 323 became an essential logistical resource in the Mediterranean theatre. Between 1942 and 1943, these giants kept the Axis armies supplied in Tunisia, Sicily and Crete, transporting fuel, ammunition and spare parts to positions increasingly isolated by the Allied advance. However, their size and slowness made them easy targets. In April of 1943, 19 Me 323 crossing the Mediterranean from Italy to Tunisia were intercepted by British Spitfire and Beaufighter fighters. All were shot down from then on. Flights were limited to night or carried out under escort, but losses remained high. Pilots described handling it as flying with a winged building, slow to climb, heavy in every maneuver, but surprisingly resilient. Many returned to base with 1 or even 2 engines shut down. In total, about 213 units were built, and although their tactical impact was limited, their logistical contribution proved crucial in the most difficult moments of the conflict. The Messerschmitt Me 323 Gigant embodied both the technical ambition and the limitations of Nazi Germany in air warfare. It was a symbol of the effort to dominate large-scale logistics through the power of engineering, a reminder that in modern warfare, supply can be as decisive as combat. Messerschmitt Me 323 Gigant, the colossus of the skies. In the Porsche workshops on the outskirts of Stuttgart, a vehicle began to take shape that seemed more like an engineering experiment than a weapon of war. It was named Panzerkampfwagen 8 Maus, and its mere presence challenged the limits of land mechanics. With 188 tons of weight and almost 11 meters in length, it was larger than a city bus and as tall as a 2-story house. Its frontal armor of 240 millimeters made it, in theory, an invulnerable adversary. The design was divided between 2 titans of German industry. Porsche KG handled the propulsion system and chassis, while Krupp manufactured the turret and armor. From the start, each part represented a new problem. There were no cranes capable of lifting it, nor bridges that could support its weight. The tracks had to be reinforced with special steel, and the suspension, built from scratch, barely managed to move the colossal mass. To propel it, a Daimler-Benz MB 509 12-cylinder engine with 1,080 horsepower was chosen, the same derived from German aviation engines. This engine powered a generator that, in turn, supplied energy to 2 electric motors, one for each track. The system, known as electric transmission, allowed smoother and more precise control than traditional mechanical transmissions, but added considerable weight and caused failures due to overheating. Later, a diesel version, the MB 517, was tested with the aim of increasing range, although it was never used in combat. Its turret, a structure of more than 50 tons, mounted a main 128mm KWK 44 L55 cannon capable of destroying any Allied tank at more than 2 kilometers away. Next to it was integrated a secondary 75mm cannon for light targets and an MG-34 machine gun for close defense inside. The space was suffocating. 6 crew members shared a closed and noisy compartment with forced fans to dissipate engine gases and firing fumes. In 1943, the first 2 prototypes were assembled. Krupp manufactured the turrets in Essen, while Alket in Berlin worked on the chassis. Allied bombings delayed the program, and the first example was completed without a turret. The second, with full armament, was transferred to the Böblingen test field. The tests demonstrated the obvious. The mouse was practically indestructible, but also unusable outside test tracks. Its speed did not exceed 20 kilometers per hour, and no bridge could support its weight. Not even the railways could transport it without special modifications. At the beginning of 1944, when the war was already tilting against Germany, the Ministry of Armament ordered the project to be stopped. The 2 prototypes were partially destroyed to prevent their capture, but Soviet troops recovered the remains and sent them to Moscow. At the Kubinka Proving Ground, Red Army engineers reconstructed a single mouse, combining the chassis of one with the turret of the other. Today, that gigantic relic is exhibited at the Kubinka Tank Museum, where its mass and its silence narrate a story of overflowing ambition. Fieseler Fi 103R Reichenberg, the flight without return. The Fieseler Fi 103R was a manned version of the V-1 missile, developed by the Fieseler Company in 1944 under the supervision of the Cassel Test Command. The V-1 structure was modified to include a tiny cockpit in the nose, with basic controls and a metal windshield. There was no landing gear. The apparatus had to be launched from the air, coupled under the fuselage of a Heinkel HE-111 bomber, and its pilot only had a parachute. On paper, it was to guide the missile to the target, aim at ships or Allied positions, and in theory, jump seconds before impact. The program was organized under the designation Leonidas Staffel, in homage to the Spartan warriors. Its promoter was the test pilot Hanna Reich, who participated directly in the development and even tested some prototypes in flight. Werner Baumbach himself, an expert in Luftwaffe special missions, supported it at the beginning. Although he soon warned of the extreme risks of the project, the first tests were carried out with unpowered versions, launched from medium altitude to check stability. The result was unstable. The small fuselage vibrated strongly, and control was easily lost when trying to correct the course. On several occasions, the test pilots barely managed to get out before the apparatus crashed. With those observations, 4 different versions were built, designated Reichenberg 1 to Reichenberg 4. The first 3 were training models, while the last, the IV, was the attack one. The interior space was minimal: a seat, a throttle control, and a small panel with gauges. On the sides of the pilot ran the fuel system that fed the pulse engine, identical to that of the V-1. Once ignited, the noise was deafening, and the vibrations could break the instruments. The instructors explained that in case of emergency, parachuting out was practically impossible, since the high-speed airflow prevented leaving the cabin despite the difficulties. Production continued in an underground plant in Dannenberg, where more than 170 units were assembled. The German technicians hoped to use the Reichenberg against Allied ships during the advance towards Normandy, but it was never used in combat. The senior Luftwaffe commands, including Adolf Galland, considered the idea ineffective and morally unacceptable. According to reports, even Hitler was reluctant to authorize a suicide weapon, since he believed that such sacrifice should remain outside the model of German military discipline. By March of 1945, the project was suspended. The completed devices were stored unused and many were destroyed by bombings. When Allied troops occupied Germany, they found several intact specimens in the test hangars. Some were sent to England and the United States for analysis, along with V-1 and V-2 missiles. One of the few preserved Reichenberg can be seen today at the Royal Air Force Museum in London. Another specimen, partially restored, is on display at the Smithsonian Air and Space Museum, where it is shown next to a standard V-1 to highlight the transformation of the projectile into a rudimentary aircraft. Sturmtiger, the hammer of the ruins. In 1943, when European cities had become battlefields, the German command sought a vehicle capable of demolishing entire fortifications with a single shot. Thus was born the Sturmtiger, a rocket launcher mounted on the chassis of the famous Tiger West. Its function was to accompany infantry in urban combat and clear paths through resistant buildings. The project began after the failure of the assault on Stalingrad, where common armoured vehicles could not confront the fortified positions. Engineers from Henschel and Alkit adapted the Tiger I base, replacing its original turret with an armoured superstructure more than 15 centimetres thick. On the front, a modified naval cannon was installed, the Raketenwerfer 61, capable of launching 380mm projectiles weighing more than 300 kilograms. The weapon operated with a rocket propulsion system. Each shot generated such a strong shock wave that the vehicle had a ventilation mechanism to expel the gases before loading the next one. The ammunition was stored in internal compartments and loaded manually with the help of a small crane mounted on the roof. The Sturmtiger retained the engine and suspension of the Tiger Rattan, which gave it reasonable mobility despite its enormous weight inside. The crew consisted of 5 men: driver, gunner, loader, radio operator, and commander. Vision was limited, and the heat generated by the rocket launcher made conditions inside the vehicle extreme. Even so, its crews considered it safer than conventional tanks due to the almost impenetrable frontal armor. The first specimens were completed in the summer of 1944. In total, 18 units were manufactured, all destined for small detachments called Sturmmörserkompanien. Its baptism of fire occurred during the Warsaw Uprising, where they were used to raise the positions of the Polish insurgents. Reports from the time indicate that a few shots were enough to reduce a multi-story building to rubble. After Warsaw, the Sturmtigers were deployed on the Western Front, especially during the Ardennes offensive. There they acted more as mobile artillery pieces than assault tanks. The mountainous terrain and winter weather hindered movements, and the lack of fuel forced them to be limited to short missions. Many were abandoned or destroyed by their own crews to avoid capture. The Sturmtiger stood out for its power, although its low rate of fire, limited ammunition quantity, and enormous size reduced its effectiveness. At the end of the conflict, only a few units survived, one of them preserved today at the Munster Museum, Germany. Jagdtiger, the monstrous German tank destroyer that almost destroyed itself. The Jagdtiger was the largest combat vehicle to operate during the Second World War. Based on the Tiger II chassis and armed with a 128mm cannon, this tank destroyer of more than 70 tons combined extreme power and constant fragility. Its frontal armor, more than 20 centimeters thick, resisted almost any impact, and its cannon could destroy an enemy tank several kilometers away. It was the heaviest vehicle that actually fought, only surpassed in mass by the Maus, which never entered action. Development began in 1943, when a tank destroyer capable of stopping the advancing Allied tanks on all fronts was sought. Henschel built the chassis, and Krupp manufactured the fixed superstructure, replacing the Tiger's rotating turret with an armored block where the main weapon was integrated. That design increased protection, but also limited the firing angle, forcing the entire vehicle to move to aim sideways. Its power was devastating. Although its size made it a target difficult to conceal inside, the space was minimal. The crew of 6 men worked amid the engine heat and the deafening noise of the shot. Each shot generated such a strong recoil wave that the internal mechanisms needed constant review. The transmission gears broke easily, and the tracks tended to come off when turning sharply. In soft terrain, The vehicle could get stuck in a matter of minutes. Despite its limitations, production started in 1944. Allied bombings on the factories and the lack of materials reduced manufacturing to about 70 units, assigned mainly to the 653 and 512 battalions. These tank destroyers entered service at the end of the same year, first on the Eastern Front and then on the Western. Their performance was irregular. They could destroy any enemy armored vehicle, but their slowness and mechanical breakdowns made them vulnerable before firing. During the Ardennes offensive, numerous Jagdtiger broke down before entering combat. Others were abandoned or destroyed to prevent their capture. On the front, they acted more like mobile bunkers. Their cannon was devastating, but the scarce maneuverability and enormous weight prevented them from moving effectively, especially in urban terrain or damaged roads. At the end of the war, the lack of spare parts and fuel left many Jagdtiger abandoned. Some were sent to museums, such as those in Bovington and Munster, where they are preserved as an example of the technical limit reached by German engineering. Volkswagen Schwimmwagen, the car that floated. The Volkswagen Schwimmwagen was the most produced amphibious vehicle of the Second World War. Designed by Ferdinand Porsche in 1941, it combined the lightness of the Kübelwagen with a structure capable of moving both on land and in water. Its appearance resembled that of a small off-road vehicle with rounded lines and a foldable propeller at the rear. It became an essential means for reconnaissance and transport in terrains where other vehicles became immobilized. Development began when the German army sought a versatile car that could cross rivers without the need for bridges or barges. From the chassis of the Volkswagen Type 82 Kübelwagen, the engineers at the Stuttgart plant built the first prototypes, called Type 128. They were longer and heavier but sank easily. After numerous tests, the frame size was reduced, the body was completely sealed, and the Type 166 was born, the definitive version that would enter production in 1942. The Schwimmwagen had all-wheel drive on the four wheels, with the possibility of disconnecting the front axle when not needed. The engine, located at the rear, was a four-cylinder block of a little more than 1 litre. The same as that used by the Volkswagen Beetle on land, it could reach about 90 kilometers per hour, and in water it advanced at about 10 thanks to a propeller that was lowered manually and actuated from the engine. To maneuver in water, the driver used the front wheels as a rudder, which gave it good response and control in calm rivers or canals. The sealed hull was made of pressed steel and had a curved design that helped maintain buoyancy. The seats were simple, and the instrumentation was limited to a speedometer and a fuel gauge. At the rear, tools, a shovel, and a hook for towing light trailers or small boats were placed. It was not a comfortable vehicle, but it was extraordinarily useful. The troops used it to transport messengers, officers or radio equipment in swampy areas or on roads destroyed by bombings during the war. Production reached more than 15,000 units, most manufactured in the Wolfsburg and Stuttgart plants. The Wehrmacht used it especially on the Eastern Front, where rains and thawing turned roads into impossible mud for conventional trucks. It was also seen in Africa and Italy, where its amphibious capabilities allowed crossing rivers without waiting for engineering support. Each reconnaissance division usually had several of these vehicles, which served both for exploration and liaison missions. The Schwimmwagen stood out for its simplicity and reliability. After the war, several examples passed into civilian hands or museums, such as the Automuseum Volkswagen in Wolfsburg, where it is preserved today as one of the most versatile vehicles of its time. Sd.Kfz 2 Kettenkrad, the motorcycle that walked on tracks. Officially designated as Kettenkrad HK101, the Kettenkrad was one of the most unique vehicles of the German army. Its hybrid design combined a front wheel with a rear track system, which gave it outstanding mobility in mud, snow or sand. Thanks to its compact size and effective traction, it could advance through terrains where trucks and tanks became immobilized. The design originated in 1939 at the NSU Motorrennwerke AG factory in Neckarsulm. The engineer Heinrich Ernst Kniepkamp developed a prototype intended to tow gliders and light artillery. Its four-cylinder engine, the same as the Opel Olympia, offered 36 horsepower and allowed it to reach about 70 kilometers per hour on the road, an unusual speed for a tracked vehicle. Although at first it was conceived for aerial use, its versatility caught the attention of the army, which adopted it as a tactical vehicle for all types of terrain. The chassis was built with pressed steel and a torsion bar suspension system derived from light tanks. It weighed about 1.2 tons and could carry up to 3 occupants. Steering was done with a handlebar, but in tight turns it relied on a differential brake system that made the tracks turn in opposite directions. In the early models, the front wheel could be completely removed to increase maneuverability in mud or snow, a feature that was maintained throughout production during the war. The Kettenkrad was used on almost all fronts. Paratroopers used it to tow light cannons or transport supplies from landing zones. On the Eastern Front, it served to move ammunition and evacuate wounded through destroyed roads or under snowstorms. In Africa and the Balkans, its compact size made it ideal for reconnaissance tasks. It was also common in airfields, where it was used to tow Messerschmitt Me F-109 and Focke-Wulf FW-190 aircraft to the runway. Serial production began in 1940 and continued until 1945. Around 8,000 units were manufactured, first at the NSU Motorenwerk plant and later at Stover Werk in Stettin. As the war progressed, simplified versions were introduced with fewer chrome elements and rougher finishes. The final model, designated HK-102, maintained the same basic structure, but with adjustments to facilitate maintenance and reduce costs. It was a highly appreciated vehicle for its reliability. It consumed little fuel, could tow up to half a ton, and crossed terrains where tanks got stuck. After the war, the Kettenkrad continued in civilian and agricultural use, and many units were exported or restored. Today it can be seen in museums and private collections, a symbol of German mechanical reliability. BMW R75 with sidecar, the three-wheeled motorcycle of the front. In 1941, the German firm BMW Motorrad presented a motorcycle destined to redefine the mobility of the German army. The BMW R75, designed in the midst of the Second World War to meet the demanding requirements of the Wehrmacht, the R75 combined the speed of a motorcycle with the stability of an all-terrain vehicle. Its most distinctive feature was the sidecar with all-wheel drive, a system that transmitted power to the three wheels and allowed progress through snow, mud or sand with a security unknown. Until then, the project arose from the experience of the First World War, when conventional motorcycles proved ineffective off firm roads. In 1938, BMW started from its civilian R71 model and transformed it completely. It incorporated a flat twin boxer engine of 745 cubic centimeters, air-cooled, delivering 26 horsepower. With it, it could reach 95 kilometers per hour on the road and overcome slopes that stopped other vehicles. Its 4-speed gearbox with reduction allowed switching between road or off-road mode, and its range of up to 250 kilometers made it an ideal means for exploration, liaison, and patrolling. The sidecar, far from being a simple addition, was a structural part of the assembly. It incorporated its own transmission connected to the rear axle, independent brake, and a differential lock that improved traction in turns or unstable surfaces. From it, a companion could operate an MG-34 or MG-42 machine gun, transforming the motorcycle into a small mobile combat platform. The tubular steel chassis, telescopic front suspension and wide tires gave it uncommon resistance. Its load capacity reached 270 kilograms, enough to transport ammunition, tools or fuel. Some versions included tropicalized air filters, supports for cans or skis, and even modified radiators for the North African desert. Between 1941 and 1944, BMW manufactured around 16,500 units of the R75, while the rival company Zundap produced the KS 750 with almost identical performance. Both companies unified components to facilitate maintenance in the field, an early example of military standardization after the war. Many R75s were reused by Allied armies or converted for civilian use. Its design served as a direct model for the Soviet Ural and Dnepr motorcycles, which retained its mechanical architecture for decades today. The BMW R75 symbolizes the union between precision engineering and military necessity, a machine conceived for war that ended up marking the evolution of off-road motorcycling. Blohm Voss BV 141, the asymmetric aircraft of the Luftwaffe. Among the many experimental projects of the Third Reich, few were as disconcerting as the Blohm Voss BV 141, a reconnaissance aircraft whose design broke all the rules of aeronautical symmetry conceived in the late 1930s. It featured a unique structure. The engine and main fuselage were located on the left, while the fully glazed observation cabin extended in a lateral arm to the right. That highly unconventional arrangement was not an aesthetic whim, but a technical solution to offer the observer a 360-degree field of view, free from the obstacles of the engine or wings. The origin of the project dates back to 1937, when the Reich Air Ministry requested a new liaison and tactical reconnaissance aircraft. The engineer Richard Vogt, from the Blohm and Voss company, presented an asymmetric concept that challenged aerodynamic conventions. Vogt reasoned that if the structure was properly balanced, the aircraft could fly as stably as a conventional one, but with incomparable visibility. His proposal competed with the Focke-Wulf 189, although ultimately the latter would be preferred by the Luftwaffe due to its simpler production and available engines. The first prototype, designated BV 141 Fi-1, made its inaugural flight in February of 1938, powered by a 9-cylinder radial BMW 132N engine of 865 horsepower against all odds. The apparatus demonstrated balanced behavior and excellent maneuverability. To the left of the wing was the pilot next to the engine. To the right, in the glazed gondola, the gunner and the observer visibility downward and to the sides was total, ideal for photographic reconnaissance tasks. The test pilots agreed that the asymmetry was barely noticeable in flight. Encouraged by the results, the engineers developed the BV 141A series, introducing improvements in armament and flight control. However, the lack of BMW 132 engines, destined for priority bombers and transports, forced a redesign of the aircraft. Thus was born the BV 141B, equipped with the new BMW 801 of 1,560 horsepower. This more powerful engine was also heavier, so the wing was modified and the tail was lengthened in an H shape to maintain balance. Although the tests confirmed its stability, vibrations and excess weight complicated production. In total, around 20 units were built, including the prototypes. The aircraft reached a maximum speed of 370 kilometers per hour, an operational ceiling of 10,000 meters, and a range of 1,200 kilometers. Armed with a fixed machine gun in the nose, another mobile one at the rear, and small bombs under the wings, it fulfilled its function effectively, although it was never mass-produced. The BV 141 was cancelled in 1943, a victim of engine shortages and preference for more conventional designs. None survived intact at the end of the war, but its technical audacity turned it into a symbol of German experimental ingenuity. Today, it is still remembered as one of the strangest and most visionary machines in 20th-century military aviation. Henschel Hs 129, the aircraft that hunted tanks. The Henschel Hs 129 was the first German aircraft designed exclusively to attack armored vehicles. Its appearance was compact and robust, with a reduced cabin and frontal armor that made it look more like a flying tank than a conventional fighter. It was born from the Luftwaffe's need for an apparatus capable of destroying Soviet tank columns with precision. The project began in 1937, when the Air Ministry issued a call for a specialized ground attack aircraft. The Henschel company, known for its trains and industrial machinery, presented a twin-engine design with a reinforced cabin. The idea was simple: a resistant aircraft, easy to maintain, and with enough power to carry heavy armament. The first prototype flew in 1939, but initial tests showed several problems. The Argus. As 410 engines, with only 465 horsepower, were weak and caused continuous mechanical failures. In addition, visibility from the cabin was poor, which complicated low-altitude maneuvers. After the defeat of France, Germany gained access to the French-made Gnome-Rhone 14M engines and decided to adapt them to the original design. The new version, designated HS 129B, improved performance and reliability. From 1942, production began, and the first units were sent to the Eastern Front. Its structure was covered with steel armor plates that protected the pilot against light anti-aircraft fire and shrapnel. In the first combats, The aircraft showed great precision in attacking Soviet columns, although it remained vulnerable to enemy fighters. The HS-129 had several models depending on the armament installed. The initial versions carried 20 and 30 mm cannons, sufficient against light vehicles. However, as the T-34 and KV-1 tanks appeared, the B-3 version was developed, equipped with a 75 mm BK 7.5 cannon, adapted from the PAK-40 anti-tank gun. This enormous cannon, mounted under the fuselage, made the HS-129 one of the most heavily armed aircraft of the war. Its power was impressive, but the weight of the weapon reduced maneuverability and required great skill from the pilot. The cabin, with limited space, had only the essential instruments. The windshield was made of armored glass, and the seat was inside a metal capsule. Side visibility was minimal, and the pilot depended on the gunner or his own intuition to dodge attacks. Even so, many considered it a resistant aircraft, capable of returning to base with impacts that would have destroyed other apparatuses. In operations, the HS-129 was used mainly on the Eastern Front, where it was nicknamed the Tank Destroyer. It also participated in Tunisia, supporting the Africa Corps, although desert conditions and spare parts shortages limited its effectiveness. The German pilots who used it highlighted its ability to strike with precision, but also pointed out its deficiencies: lack of power, slowness in climb, and vulnerability to Allied fighters. Total production barely exceeded 800 units, a small number compared to frontline needs. In 1944, with scarce resources and the military situation deteriorating, the program was cancelled. Some aircraft survived until the last months of the conflict, used by the Luftwaffe in desperate support missions. No complete example of the HS-129 was preserved, but its design marked the origin of future ground attack aircraft. Porsche Type 64, the origin of the lineage. In 1938, ahead of the imminent Berlin-Rome race, conceived as a great propaganda showcase, Ferdinand Porsche developed a vehicle that combined lightness and aerodynamics. Its purpose was to demonstrate German technical capability and serve as a showcase for the incipient Volkswagen project. From that work was born the Type 64, an aluminum automobile considered the starting point of Porsche sports cars. The design was elaborated in the Porsche Bureau, based on the plans of the Volkswagen Type 60, precursor of the future Beetle. The model name reflected its link to the original Volkswagen. The Type 60K10 referred to the fact that its body number 10 came from that first design. Much of its parts came from the Volkswagen 38, the first prototype of the German Labour Front car. The chassis was reinforced to withstand higher speeds, and the engine was modified to reach about 40 horsepower. Allowing it to reach about 160 km per hour. It had a rear-mounted four-cylinder flat and compact engine, a configuration that years later would become characteristic of the brand. The cabin was narrow, with only 2 seats and an extremely simple interior, designed exclusively for racing. The body, manufactured in aluminum by the Ratte company of Stuttgart, which was already collaborating with Porsche on the first Volkswagens, was completely hand-molded and tested in a wind tunnel to optimize aerodynamics. The result was a low and elongated car, with covered wheel arches and a curved windshield that anticipated the lines of future models. Although its appearance resembled a closed coupe, it still retained features of the Beetle, especially in the front part, which facilitated its homologation for the planned race. The project had a clear objective: to participate in the Berlin-Rome race, scheduled for September of 1939. It was expected that the event would show the world the advances of the German automotive industry and the power of its vehicles. However, the outbreak of the war prevented the competition from taking place. Even so, 3 units of the Type 64 were built before the conflict. The first was destroyed in the early months of the war, while the other 2 remained in the hands of the Porsche family. One of them was stored, and the other was used for transfers between the plants in Zuffenhausen, Wolfsburg, and Berlin. In 1945, when the Allied troops reached Austria, the American soldiers found the car that had remained stored. They cut off the roof and used it for weeks as a recreational vehicle, until the engine was damaged and it was finally discarded. The other specimen, owned by Ferry Porsche, managed to survive the end of the war. 2 years later, it was restored by Battista Farina, the Italian designer who would later direct Pininfarina. With that same car, Ferry Porsche participated in various exhibitions and local competitions until selling it in 1949 to the motorcyclist Otto Mattei, who drove it in several races and won with it the Alpine Rally of 1950. Mattei kept the car until his death in 1995, and subsequently it was acquired by the Austrian collector Thomas Gruber, specialized in Porsche models. The surviving specimen has been shown in museums and auctions around the world. In 2019, it was scheduled for sale during the Monterey Car Week, with an estimated price of more than $20 million, although the auction was cancelled due to a technical error. The other vehicle, lost during the war, was rebuilt years later with recovered parts, and today is exhibited at the Peterson Automotive Museum in Los Angeles. Both shared the same lightweight structure, the rear engine, and a design conceived for speed. Its creation marked the exact point at which Ferdinand Porsche's engineering passed from the popular-use Volkswagen to a purely sporting concept. The Type 64 is still preserved in the Porsche Museum in Stuttgart, with its original metallic appearance, as the piece that gave origin to one of the most emblematic lines in the history of the automobile. Junkers Ju-87 Stuka, the screaming bomber. The Junkers Ju-87, known as Stuka, was the most feared dive bomber of the Second World War. Designed by Hermann Pohlmann in the mid-30s, it became the symbol of the Blitzkrieg, the German tactic of rapid and coordinated attacks, its structure with wings in the shape of inverted gull, and the sirens mounted on the landing gear made it unmistakable. The prototype flew for the first time in 1935, powered by a Junkers Jumo 210 engine. From the beginning, an aircraft was sought that could drop bombs with great precision. The Stuka descended almost vertically, released its load, and recovered through an automatic system that prevented the pilot from losing consciousness due to G-force. Its reinforced structure and fixed landing gear made it stable and resistant, although also heavy and not very agile. The apparatus entered combat for the first time during the Spanish Civil War, integrated into the Condor Legion. There it proved its effectiveness by destroying bridges, fortifications, and convoys. The lessons obtained in Spain led to improvements in the Ju-87B model, which incorporated a more powerful engine and an aerodynamic fairing. In 1939, it was already the standard close-support bomber for the Luftwaffe. At the beginning of the Second World War, the Stuka played a key role in the invasion of Poland, Norway, and France. Its dive attacks cleared the way for ground troops and sowed chaos among the defenders. The characteristic howl of the trumpets of Jericho, sirens with no practical function installed on the landing gear, served as a psychological weapon that announced the imminent bombing. During the 1940 campaign, the Stukas destroyed ports, enemy columns, and coastal positions, although their lack of speed made them vulnerable to British fighters. In the Battle of England, dozens were shot down by Spitfires and Hurricanes, which forced the temporary withdrawal of the model from the western skies. Subsequently, it was transferred to the Mediterranean and the Eastern Front, where its attack power continued to be valuable. The Ju-87D and Ju-87G variants incorporated additional armor, new engines, and anti-tank cannons under the wings. The G version, nicknamed Kanonenvogel, mounted two 37mm cannons capable of piercing the armor of Soviet tanks. These modifications allowed it to survive in an increasingly dangerous environment. Even so, its low speed made it dependent on friendly fighter cover. The Stuka's cockpit was simple but functional. It was piloted by two crew members, the pilot in front and a gunner behind. In charge of a defensive machine gun, it could carry up to 500 kilograms of bombs in the central fuselage and two smaller bombs under the wings. Its Jumo 211 engine provided a maximum speed close to 400 kilometers per hour, sufficient for dive attacks but insufficient to escape enemy fire. The Ju-87 Stuka continued in service until the end of the war, despite being outclassed by Allied fighters. Today, some restored specimens are preserved in museums in Germany, the United Kingdom, and the United States. Focke-Achgelis Fa 330, the submarine's eye. The Focke-Achgelis Fa 330, known as Bachstelze, wagtail in German, was one of the most unusual projects in German aviation during the Second World War. It was a light autogyro towed by submarines, designed to expand the visual field of the U-boats when sailing on the surface. Its purpose was to detect enemy ships at great distance without the submarine having to expose itself too much. The apparatus was designed in 1942 by the company Focke-Achgelis, founded by Heinrich Focke, a pioneer in rotor flight. Unlike a helicopter, the Fa 330 had no engine. Its rotor spun, driven by the relative wind generated, while the submarine advanced at about 30 kilometers per hour. The apparatus remained attached to the ship by means of a steel tow cable of about 150 meters, and thanks to its tubular aluminum structure, weighed little more than 70 kilograms. The crew member traveled seated in a small metal chair, with his feet resting on a semicircular frame and a basic compass in front of him. There was no cabin or protection, only a safety belt and a parachute in case of emergency. When the submarine needed to dive quickly, the cable was released and the pilot descended by parachute, although this maneuver was risky and was rarely practiced. The first tests were carried out with the U-177, a Type 9D2 submarine. The system proved useful in calm seas, especially in the Indian Ocean, where visibility was wide and weather conditions more stable than in the Atlantic. From a height of about 120 meters, the observer could spot targets up to 40 kilometers away, which notably increased the visual range of the ship. The Fa 330 was simple to assemble and disassemble. It was stored in three main sections: the foldable rotor, the central body, and the seat assembly with rudder. The crew could assemble it in about 15 minutes. Even so, its use presented major drawbacks. It required the submarine to sail on the surface and at constant speed, which made it vulnerable to Allied aircraft. For this reason, it was only used in specific operations, mainly in the Indian Ocean, far from enemy air cover. By mid-1943, about 200 units were built, but most remained stored without assignment. The Naval Command considered the device too dangerous for the North Atlantic. Despite its scarce practical application, the Fa 330 demonstrated the ingenuity with which Germany tried to compensate for technological inferiority against Allied radar systems. One of the few records of effective use occurred with the U-177, commanded by Heinrich Schonder, when an operator aboard the autogyro detected an enemy freighter off the coast of Madagascar. The sighting allowed the submarine to intercept and sink the target. However, this type of success was exceptional. Most missions were limited to observation patrols or training. The Fa 330 was studied by the Royal Navy after the war and proved to be stable, although limited. Today, some examples are preserved in the Fleet Air Arm Museum in the United Kingdom and in the German Museum in Munich. Borgward IV, the unmanned tank. The Borgward IV, officially known as Sd.Kfz 301, was one of the first radio-controlled vehicles created by Germany during the Second World War. Its main function was to transport explosive charges and detonate them at a distance. Although its size was similar to that of a small light tank, its interior only had space for a driver, and in combat, it was operated remotely. It was an attempt to turn remote control technology into a practical tool of destruction. The project began in 1942 under the direction of the Borgward Company, based in Bremen. The idea arose from the need to breach fortifications or minefields without risking crews. The first models, called Ausführung A, were powered by a six-cylinder Borgward engine of 49 horsepower and weighed about 3 tons. The structure was formed by steel plates between 8 and 20 millimeters thick, enough to withstand light fire. At its rear, it carried a detachable explosive charge of 500 kilograms that could be dropped or detonated according to the order received. During its initial phase, the vehicle had a driver who took it to the launch area. Once positioned, the operator descended and control was transferred by radio to a command vehicle, generally a Panzer III or a Sturmgeschütz III, which sent the direction and detonation signals. This method allowed for some precision in movement and reduced human losses. However, the system was complex and required clear terrain to maintain stable communication. Field tests were carried out in 1943. The results were satisfactory in demolition operations, but its effectiveness in real combat proved limited interference problems. The restricted radio range and the vehicle's vulnerability meant that many units were destroyed before fulfilling their objective. Despite this, the Army approved improved versions, Ausf and Ausf. C, with more powerful engines, up to 78 horsepower, reinforced transmissions, and wider tracks. These versions increased speed to 38 kilometers per hour and improved maneuverability in mud or snow. The Borgward IV was employed by the Panzerabteilung 301 and 302 battalions, which used it on the Eastern Front and during the Warsaw Uprising in 1944. In these operations, it was used to destroy barricades and fortified buildings. Reports from the time highlight its precision in urban missions, although its low resistance to direct fire remained a problem. It was also employed as a support vehicle to clear mined areas before the advance of heavy tanks. As the war approached its end, several Borgward IV were modified for new functions. Some units were transformed into improvised tank destroyers, called Wanzer, equipped with Panzerschreck rocket launchers. These versions operated in the streets of Berlin in the last days of the conflict. Although their effectiveness was scant, they represented the German attempt to make the most of available resources. Between 1942 and 1945, about 600 units of the Borgward IV were built. The Soviets studied several captured specimens in Kubinka, and today some are preserved in museums in Germany, Austria and Russia as precursors to modern unmanned vehicles. Schienenwolf, the plough of destruction. The Schienenwolf, also known as Schwellenpflug or sleeper plough, was one of the most singular devices in the German railway system during the Second World War. It was not a direct combat weapon, but a tool for massive sabotage created to disable enemy tracks. Its purpose was clear: to leave behind a trail of destruction upon withdrawal that would prevent the advance of Allied armies. The device was developed by the Krupp Company in 1942, following an order from the Deutsche Reichsbahn and the Reich Ministry of Transport. At first glance, it looked like an ordinary wagon, but under its structure it hid a huge tempered steel hook that could descend between the rails. When the train started moving, the hook tore the sleepers and twisted the rails as if they were paper. The machine did not fire projectiles or bombs, but its effect was devastating. A single pass was enough to disable entire kilometers of railway. The system was relatively simple. The Schienenwolf was coupled between two locomotives or at the end of a train. The hook, weighing almost 1 ton, was lowered by a hydraulic or manual mechanism until it touched the sleepers. Once in position, it advanced at a constant speed of 7 to 10 kilometers per hour, breaking the wooden framework and lifting the rails continuously. The noise of the metal tearing the track could be heard hundreds of meters away. In a few hours, a single team could ruin dozens of kilometers of railway line. Assembly required between 6 and 8 minutes, and the work was carried out by a crew of 10 men. Some models included a small cabin to protect the operator from fragments. The heavier versions had a suspension system that maintained the wagon's stability during dragging. The original design was successfully tested in Poland and Ukraine before general deployment. The Schienenwolf was part of the scorched earth policy that Hitler imposed in the last years of the war. Every time German forces withdrew, they had to destroy all infrastructure that could be useful to the enemy. High command reports indicated that in practice, the use of these devices delayed the Soviet advance by up to 3 days. The time it took to rebuild the damaged sections, German troops employed them, especially during withdrawals in 1944, both on the Eastern Front and in Italy and the Balkans. Its effectiveness depended on the type of track. In mountainous areas or with tight curves, the hook could jam or break, so it was often accompanied by explosives to complete the destruction. Later models included steel reinforcements on the main arm and a spring system that absorbed part of the impact. Although there were attempts to automate the process, the basic version remained the most common due to its speed and reliability. Unlike other war devices, the Schienenwolf was not a secret or experimental project. It was part of the standard equipment of military transport units. Its simplicity of manufacture made it accessible even to local railway workshops, which could build improvised versions with available materials. In some cases, variants mounted on shorter platforms were adapted to operate in urban areas or industrial sections. After the war, several Schienenwolf were studied in Moscow and exhibited in museums in Belgrade, Sarajevo, and Poklonaya Gora. Its simplicity and effectiveness made it one of the most characteristic railway sabotage tools of the conflict. Tatra T87, the car that scared Reich officers. Designed in 1936 in Czechoslovakia by Hans Ledwinka, the Tatra T87 represented one of the peaks of pre-war aerodynamic design. Light, Built in aluminum and with a streamlined body that anticipated lines from decades later, it could reach 160 kilometers per hour with just 1,400 kilograms of weight, a surprising figure for its time. Its heart was a 3.4-litre V8 air-cooled engine placed behind the rear axle. It delivered about 75 horsepower, enough to make it one of the fastest touring cars of the pre-war period. The structure included a vertical dorsal fin that helped maintain stability and 3 symmetrically arranged front headlights with one central over the Tatra emblem. The interior, elegant but sober, showed the functional Czech style, polished metal dashboards, ergonomic seats and wide windows that favored visibility. When Germany occupied Czechoslovakia in 1939, the car became an object of desire among the officers of the Reich. Its speed, exotic design and futuristic bodywork turned it into a status symbol within the army. Generals, commanders and high-ranking bureaucrats began using it for official travel. However, the T87 hid a trap. Its rear suspension system with swing axles and its weight distribution made it very difficult to control in curves. At high speed, the car tended to oversteer, causing skids and road departures. Accidents became so frequent that the vehicle gained a reputation for being dangerous. According to contemporary reports, in a single week up to 7 officers would have died driving it. That reputation spread among the troops until it reached Adolf Hitler himself, who supposedly banned its use within the army. From then on, the T87 went from being a symbol of prestige to becoming a silent warning about the risks of advanced technology without adequate preparation. During its production period between 1936 and 1950, about 3,000 units were manufactured. Each one was hand-assembled, and many were destined for high-ranking officials or diplomatic missions. Unlike other automobiles of the era, the T87 could cover long distances with surprisingly low consumption, about 12 litres per every 100 kilometers, thanks to its advanced aerodynamics. It was also one of the first cars to use mixed materials of aluminum and magnesium, reducing weight without compromising the rigidity of the chassis. Over time, the Tatra T87 became a cult object. After the war, several examples were exported and today are preserved in museums in Europe and the United States as examples of a design ahead of its time. Thus concludes the history of the 20 most fascinating and terrifying vehicles of Nazi Germany, machines that reflected both the technical genius and the excessive ambition of an era in which engineering was put at the service of war. Some marked the course of modern technology, others remained as a warning of how far the obsession with power can go.